Good. I can't complain. Can't complain. I've got a typical question for you, but you're usually telling me that I'm calling you too late. I promise you I'm calling you early this time. So there's lots of
Okay.
options early. I bid on an RFQ for a solar array installation. The real question I have is the contract is the solicitation is written a little differently than I'm used to. I'm sure this is common for other people, but they asked me to confirm my quote, and obviously I'm like pouring through every detail as I usually do. And there's something in there that is just, again, something I'm not used to. They are asking me to design the size of the solar array system to meet their needs. There is some criteria about what their power usage is, but the wording of the contract is not, we want this size system and install it. The wording of the scope of work is, this is how much power we use, give us a system that meets this. And I believe I'm on par with what they're looking for. But the kicker is, it is the Corps of Engineers, so I know I'm going to get my ass handed to me if this system is too small at all. So I'm sure this is probably normal to have to be, for the design portion, to be on the contractor a little bit, but I've never really dealt with that. So I was wondering if there's any specific things I need to be asking or looking at, or just how I should be treating this differently than I want 10,000 square feet of carpet, here you go, replace it.
Okay. So I'm not a solar panel expert, but
Mm-hmm.
but I know a bit about it. I can have an intelligent conversation with somebody about solar.
Mm-hmm.
And uh, I don't know what the name of this equation is, but it's volts times amps equals watts.
Mm-hmm.
You ever heard that before?
I haven't heard that before, but not that specific term. But I, again, like you, I get the very 101 level of a solar panel system. But
Okay.
continue.
So anytime I'm thinking about solar, I'm the first thing I'm thinking is volts times amps equals watts.
Mm-hmm.
So you got a 100-watt solar panel.
Mm-hmm.
You hook up a 100-watt solar panel to a 12-volt battery, and it will charge it in full sunlight, usually something between 80 and 90% efficiency. So you'll get 80 watts going into the battery. But again, it's volts times amps equals watts. So what
Mm-hmm.
is the voltage in this scenario of a 100-watt solar panel? Well, typically it's about 18 volts. Now, someone at a 101 level might go, well, wait a minute, 18 volts, you got a 12-volt battery, that doesn't equal. Well, it turns out when you hook up in order to charge a 12-volt battery, you need to be putting in more volts than what the battery is itself. Okay?
Uh-huh.
So a typical 12-volt battery will charge up to, let's say, 14 volts. Well, you're at 18 volts, so that'll charge it plenty up. You'll use a charge controller that will
Uh-huh.
cap it off at 14 volts based on a 12-volt system, something like that. Okay, now the
Uh-huh.
amperage part of it. Well, if you've got volts times amp equals watts, you got 80 watts going in, you divide 80 by the 12 volts, and that'll tell you your amperage, right?
Uh-huh.
Okay, and so that will help you size the wire that'll be coming from the solar panel to the battery, because wire sizes will handle different amperage loads.
Uh-huh.
Okay, so that's the basic mathematical process. Now, Let's talk about what they said that, what are they using the solar system for?
I did it like a month and a half ago. I've only skimmed through it again right this second.
Okay,
But
the reason
they have
I'm
a
at,
small
then let me
office.
explain why I'm asking.
Yep.
Typically, solar systems are used basically two different ways. There are others, but the basic two are: number one, hooking up a solar panel to tie into the grid. They call that a grid tie system, okay,
Mm-hmm.
where they're just generating power and giving it back to the grid.
Yes.
The second main way of doing is some kind of backup system. In other words, like what I have at my house. I have solar
Mm-hmm.
panels at my house, but they're not tied into the grid and they're not tied into the house power. They are
Mm-hmm.
consistently and constantly powering a battery system that I have here. And then I have four circuits of my home that are tied into that battery system. So that essentially I've got four circuits in my house that are consistently and constantly on uninterruptible power. In other words, if the power goes out at my house,
Yes.
my devices and my TVs and my lazy boys and all that shit stays on
Mm-hmm.
and just runs off batteries and the sun if it's during the day. But even if it happens during the night, it'll I got something like 8 hours capacity of batteries.
Yes.
So
And that's the way they're intending on using it. But obviously, the way you said that and my lack of confidence, I need to be a little more detailed about. I need to really focus in on how exactly what systems they're looking to run on that, not just the amount of power they think they want. Okay.
that I was hoping that something I said here would help you based on your scenario.
Yeah, certainly.
so
Certainly.
so let me get a little more specific about my system, and that'll help you incorporate whatever you're happening on your side. So specifically on this battery backup system that I have. So I have two systems of solar at my house. One is for this battery backup system, and the other one is I have a DC powered mini split air conditioner.
Okay.
That means that I can run the air conditioner directly off of solar. There's no inverter, no nothing.
Okay.
And it's a dual input power, so it primarily runs off solar, but if there is no solar, it'll switch over and run off 220 on the house. Obviously that won't work
Mm-hmm.
if there's no power at the house, but I can be in full power outage, and if the sun's out, I've got a 2-ton air conditioner that runs off solar.
Mm-hmm.
But that's pretty nice. But that's a direct current directly connected to the solar panels. It's got literally I think they call them M4 connectors, uh, directly to the solar panels, and it shines a big green light on it when it's running off of solar, and it's freaking wonderful because you're looking at that going, holy shit, that is literally free air conditioning.
Yes.
Okay, but let's talk about the battery system. On the battery system, I only have 1,000 watts worth of solar on it that typically
Uh-huh.
runs about 850 watts of true power. Um, and that's running into the battery backup. So the battery has an inverter. In fact, mine is a all-in-one. So it's a 100-pound unit that's got massive batteries in it, and it's got a 2,000-watt inverter on it that converts DC to AC power.
Uh-huh.
And then from there, I'm powering a sub panel with those four circuits I was talking about.
Uh-huh.
So on their system, you could be using solar to power up batteries, and then the batteries would be connected to maybe a separate panel, um,
Uh-huh.
and then having circuits, run directly from that panel so that they're always running. But some panels, you can have a switch on them that says, I'm running on shore power, land power, the power company, and
Yep.
then there's a disconnect that will switch you over to running on battery backup only. And then you can also get into things called automatic transfer switches that detect a power outage and switch. And in fact, my battery backup system does have that.
Okay.
So, any questions about that?
Not on the system itself. I need to be 100% rock solid on the system itself, and I have more questions, but not too much on your end. I guess the only question that I feel like I have the most concern about is Harry plans this solar system, and it, in my mind, meets the needs of what they've described. It gets installed, and the Corps of Engineers says this isn't 5 times overkill like we usually like, but we didn't tell you to give us 5 times overkill. We told you to meet our needs. Who at the end of the day says this design meets our needs or it doesn't? And obviously, I would hope that would be done very early on before there's any groundbreaking. But just of my experience with the Corps of Engineers, I've never had a design contract with them. I don't know that I've ever had any contracts.
Do you know what an amp meter is?
I do not know what an amp meter is, but I'm assuming it's a way to measure power.
Okay, so at my house, I have 2-phase power coming into my house. It's 220 volts, 120 per line, and a neutral, and then I have a ground. Okay, you can buy an amp meter at Home Depot or Lowe's, and I have actually done this. I climbed up on a ladder. An amp meter has a clamp at the top of it, and you push a button, it opens the clamp, and you put it over the wire, and then you unclamp it. Now the wire is running through the hole.
Yeah, I've seen them used before.
Okay, that's measuring amperage. Okay. Now I know the voltage coming into my house. Okay, that's 220. Volts times amps equals
wattage
equals watts. Okay. So if I've got 100 amps running through that wire times 220, now I know the watts. Okay. You can look. A watt is a watt is a watt. Okay. So what are solar panels advertised in?
Watts.
Watts. Okay, a watt is a watt is a watt. So you can take an amp meter, go out there and put it over the circuits that they're using. And if you know the voltage, like a coffee maker, okay, a coffee maker can be 800 watts, it can be 1600 watts. But if you put, there's also another device that you can plug in the wall in between the coffee maker and the wall. They sell them on Amazon for like $20. And it'll tell you the watts that device is consuming. You can also read the label on the back of the device. Any electrical device in the United States has to have what's called a UL, Underwriter's Laboratory label on it. In fact, if you're in your house, you can go grab anything that plugs into a wall and you can see that label on it. And it'll tell you either the amps or the watts. Most of the time, it'll show you the watts. So you can add all that shit together and go, okay, tell me what everything that's going to be on at any given time, and then you can go figure it. You can add all the watts up.
Okay. Yes. Okay. So what I'm hearing is if I can be sure to show, I guess the term would be the basis of my design, which would be I can see that you're using this many watts for what you want me to power, and our design is based off that, and I can show that our design is based on that, then I'm good to go.
Yeah.
Okay.
But I mean, somebody needs to tell you, this computer's on all the time. This is the coffee maker. It comes on occasionally. Okay? This is this. This is this. You can add all that shit together. Now, look, you're not running a coffee maker 24 hours a day. That's 1,600 watts temporarily. Okay? If they've got a battery system, the battery system will absorb that 1,600 watts and then continue charging after it's done. Does that make sense?
It does, yes.
Okay, so you don't design a system over max capacity, like everything's going to be on at the same time, okay?
Right.
Because some things turn on and turn off.
Right. Okay.
But, lights, are the lights running 8 hours a day? Are they running 12 hours a day? Okay, that's when you come into what's called an amp hour. Have you ever heard of that?
Not in this context, I don't think so.
Okay, so let's talk about an amp hour. A battery is typically, what's the word on that? Advertised.
Right.
In amp hours. So you've got the voltage, 12 volts, and you got a 100 amp hour battery. Okay, what does that mean? That means that the 12 volt battery should be able to draw power off of it at 100 amps for 1 hour. Okay, now you know the voltage, you know the amps. How many watts can that thing power? Tell me.
Right.
No, I'm asking you.
1,200.
Okay.
Did you say 12 volts, 100? Yeah.
So 1,200 what?
Watts.
Okay. Tell me something in the real world that pulls about 1,200 watts.
Well, you said coffee maker earlier in 1,600.
Okay.
So I'm going to say something smaller than a coffee maker. Let's just say a Keurig or something like that.
Okay.
I don't know.
Okay, now, on a standard 12 volt, 100 amp hour battery, how long could you run that device?
If it was a 1,200...
Roughly. I'm not asking you to do math here.
You could run it for an hour.
That's right, an hour. Okay? Yep. So that tells you what kind of capacity you could get out of a 100 amp hour battery. All right? Yep. So is their facility going to be able to be run off of a 100 amp hour battery?
Well, certainly not.
Certainly not, right? So this will tell you roughly, you see how you can use math, just generalized math, to back into what size battery system they need.
Okay. Fair enough.
See, if you know volts times amp equals watts, you can always tell if somebody's trying to, blow smoke up your ass.
Right. So I'm jotting it down now, because it's going to be my favorite phrase for the rest of the day, I can see. So, which is good. All right. Well, I think I have some homework to do. As always, I appreciate you being available. I'm going to ask, how's your health been lately? Because I feel like the last few times I've called you, you've been in and out of doctor's appointments and all kinds of fun stuff going on with your eyes. So I'm hoping.
Yeah, no, everything seems to be good. Yeah, we're good to go, man.
That's awesome. That's great to hear. That's great to hear. All right. Well, if I come up with more questions, I will let you know. But hopefully, you've given me enough to do my little bit of a Solar 102 class today.
Yeah.
And yeah, hopefully, I can not make any mistakes. I definitely appreciate the help as always.
All right, Harry. Have a good one.
Thanks, Sean. You too.
Bye-bye.
Bye.